Okay, so apparently I have the last talk of the summit, right? No pressure. Just one thing. I just use the corporate slides here. I work for McAfee just because I want to get into trouble. I like getting into trouble with the legal teams about the memes and all the inappropriate images that I use on this decks. That's the only reason why. But there's no marketing, nothing, right? I'm going to try to sell you in the next 30 minutes at the very least. So that's kind of my experience. Anyone here is a geek at heart? All of us, pretty much, right? Yeah, based on the conversations we've had over these last couple of days. So I'm a geek at heart as well. I've been working in security for about 17 years. Last 3 here in the US. And I started as many of you, maybe, right? Interested into how to break into things just because you think it's fun until you realize that it's kind of boring, right? Yes, this is the right place for saying this. Go blue. So then I started to become a bit more interested into, okay, let's learn what happens when someone breaks into a computer. That's a bit more interesting, right? And the previous talk, John did a fantastic job at looking at the MITRE attack chain, and that's one of the models I use all the time, right, to try to learn what happens in each of these different stages, and it's very useful for the kind of the job that we do. So what I do now, in addition to teaching for SANS, I've been teaching for SANS for about 7 years now. And I teach Seth's and Eric's class, Security 511, awesome class, right, starting tomorrow. That's going to be great. And also next year, I will be teaching Management 517, which is the management class, the SOC management class from Chris Crowley. And 503, which is the very first class I ever taught like 7 years ago, intrusion detection, death, lots of fun, lots of packets, hexadecimal, etc. So that's kind of a bit of my background. I work as my day job is as a principal engineer at McAfee. I've been doing incident response and forensics for the last 10 years, pretty much. Now, before I get onto my topic, I want to show something that I've been told, hey, Ismael, you got to put this on the screen, right? So thanks to Stefan for the Inception game. Now, thanks to this, we can also keep the Inception going, right? Yeah, so please take a photo of that and keep it going. And to be honest, this has been so much fun, but there's been a few weird things too, right? Let's be honest. Can anyone see something weird in this picture? Seriously. 3Ms, yes. So this is the proof that we have good analysts here, right? So raise your hand, who was that? That's a surprise for you. 3Ms, yeah, we do that on purpose to figure out who's a good analyst here in class, in the summit. So one of the things that we usually do when we finish the summits, right, and Jen is going to like this, she's going to send an email to everyone thanking you for coming down to the SIM summit and hoping that we can see you next year. So yes, you're going to get an email. And as we said in the beginning of this summit, when we started this yesterday morning, we said there's lots of surprises. You're going to get lots of surprises here. So there's one more surprise. Each of you is going to get a free iPhone X, right? Woo! Right? How do you feel about that? All you have to do is to follow that link, right? Put in your details, and you're going to get a free iPhone X. Sure, right? So that's the email you're going to get. Just wait a few minutes right after the thing is done, and you'll get this. If you have any issues with that, just you can call Eric Conrad directly on his cell, right? That's his phone number. Seth just changed his, so that's why I don't have his on the screen. But there's nothing suspicious about that, seriously. I mean, I'm actually going to even show you the code, right? The code for that, the source for that email, right? Anything spooky there? That's my domain. Right? There's nothing wrong with it. Can anyone go there? Anyone using the internet? No, not really, right? Can anyone go there, see if there's something going on? Really? Something weird? Come on. You guys don't click on stuff? No? Wow. So this is legit. It's so legit that actually I'm going to show you some of the conversations that I've had with Justin about the iPhone X and more people, as you're going to see now, right? So actually, Justin is just waiting for this transfer of money from, I think he's got like a Nigerian relative, right? He's going to transfer you some money. the twins, the Nigerian twin. Wasn't he a prince or something? I thought he was a prince, right? So he's waiting for it. And he checked this link. There's nothing wrong about it. Seth also checked on it, right? Yeah, he can prove that it's totally fine. So you can go there. Nothing to worry about. Definitely not. So you're going to go there, and then just going to be asked to open up this invoice.rtf, right? Does it sound familiar to something that you might be seeing on a daily basis? Right? Isn't it? I actually have I don't have a meme for this, but I have a video, live video of a SOC analyst as he's watching this, as he's watching the user doing something like this, right? So pay attention to it, right? That's how I feel at 4 p.m. when I get my new threat intel feeds into my SIEM, right? It's like, yeah, I just want to give up. So now seriously, this is something that we see every day, right? And we've been talking about the need for getting more context, for enriching the data that we get out of our SIEMs. So some of you might have heard me before talking about these projects, an open source project I've been working with for some time. It's not rocket science. It's just a little collection of scripts that I put together while I was working out of a SOC. And I had like about over 60,000 nodes that I wanted to get information out of when they were exhibiting some suspicious behavior. And I didn't want to just open up a command line and do this manually, right? So as we said earlier on, automation, right? Try to get the most out of your time. So I did this. It's essentially a Python wrapper that can execute sysinternal commands and any other tool that you really want on the endpoint and get you a snapshot. Now, why a snapshot when you can do sysmon and you can do all of that stuff? This is not a substitution for it, right? But still, there's many other environments where, and this environment I was working at was an example of that, where they were running like 5, 6 different endpoint agents on the machine. And how long would it take them to go through another approval process for getting another agent on the system, right? How long does it take you to get something like this going on in your environment? Long time, sometimes like months, right? I can't wait for that. So I figured out these machines were running the McAfee agent, but you can run this with anything you want, even SCCM or any other kind of agent that is able to execute some binary on the endpoint. I figure out, hey, if this agent is running a system, if I can get this agent to execute my script, right, my binary, I just compile. This is frozen. It's not compiling really with Python. If I compile all of this and I execute it on the box, I can get all the information I need from these machines. So this is the result. It's a little project. I put it out there a couple of years ago on GitHub. And then I started to get emails from people in Australia. It's like, hey, thanks for this. I'm orchestrating my instant response through my EPO console with this. And some other people saying, I'm using this with SCCM and I'm executing PowerShell commands through this. And I was like, wow, why would you do that? But anyways, they were doing it. And it gave me more ideas. But that's where it is. And essentially what it does is collects information that is useful for triage. Right? So these are different commands that you can run. Now in the new version that we released earlier this year, we presented at the SOC Summit, you can also get the browsing history from all the users on that machine, or just one specific user, which is kind of useful, right, to see what's going on with that box. You can also get the prefetch. You can get a memory dump, very useful. And you can also use this for going hunting, right? Hunting in your environment for indicators of compromise. So it wraps also the Yara libraries, and you can use this to go and hunt for specific artifacts in your environment, search for artifacts in memory, and also on the disk. Something else that I wanted to do as well was to have the ability to extract certain files of interest out of these boxes. So again, without the intention of reinventing the wheel, these two folks are putting together a great open source project called CYLR. I had the pleasure of introducing them on a stage at the Forensics Summit that we did this year in Austin. And Alan and Jason, they put together this great tool that can bypass the Windows API, so you can go and extract these artifacts from raw from the NTFS, right, file system, and it does everything in memory, so it's forensically friendly, right? So that's a pretty good tool. pretty awesome. And as you will see in one of the demonstrations I will do later, with some of the screenshots, you can get all of these. The prefetch folder, you can get the MFT, you can get all of this. And MFT is awesome. It's one of the things that I always want to get out of a machine because it gives me the ability to build timelines. Right? I can get things from registry, and I can get these files, and with a few commands, with volatility, for instance, I can extract even this MFT from memory, and I can build a timeline, and I can see what's going on within a specific period of time, which is very, very useful. So you have more information about that there. Yes? I haven't tried that. Yeah, I haven't investigated many of those lately. But it might be interesting, yes. Might be interesting. So now let's assume that someone has clicked on that link, right? For that specific example, that email or that Twitter kind of message, let's assume that someone's going to click on that because we know someone's going to click on it, right? So we know it's going to happen regardless. And let's think that someone maybe told you that there's this kind of spooky thing going on or dodgy thing going on, and then they give you an alert. You know that that user is doing something weird. Well, you can use rastrea2r, right, easily to get a snapshot of this machine, and this is the kind of the format that that it's going to write into. It will create a share. There's a share folder, and we'll create a folder for each of these machines that are investigated, and then a bunch of plain text files. And for instance, that's the output of plist, showing you all the process that was running on this machine, right? If you go to the GitHub side, there's plenty of videos that will show you demos on how to run this. It's pretty simple. But essentially, you have a read-only share folder with a bunch of tools that you want to execute on the endpoint, and then you also have a write-only share folder on your environment where all of this is going to be written to, right? So now the analyst goes to that folder and it starts looking at what's going on with this machine. And this usually takes like 3 to 4, 5 minutes to complete all of this in a normal network. So let's go through this example. Let's say that we collected the browsing history. We said, hey, rastrea2r, bring me this over. And then we see something like this. Right? We're highlighting this entry here. We know that the user went to this particular IP address. Anything malicious with it? No. Why? Because it's Azure. Why? Because Carson told me that Azure is awesome. Right? Exactly. So I put my payload, my malicious payload on Azure, and it runs great. Exactly. Except when I use it. Web history, this module can give you the web browsing history of Firefox, Internet Explorer, Chrome, and even Opera, right? So it's pretty powerful. And so you can see not just the browsing history, but also the files that were opened through Explorer, right, on a Windows machine. So that's pretty useful. It will give you this CSV file that you can go through and see what's going on with this box. Now, also evidence of persistence, right? John was talking about this before. Where can you see this? So you can run these tools like a startup list, auto runs from Sysinternals, and when we open that up, right, we open that plain text file, we can see that there is clear evidence of persistence there, this weird Visual Basic script, and that it's trying to run something out of that registry key. What else? If we get the process list, we can also see that there is a process there that's doing something strange. Let's zoom in. Does anyone recognize that process? AQNet DT32. What is that? And what is that? It's your new best friend, right? It's also my new best friend, too. Right. Yep, more on that later. But yeah, this is my new best friend, and it should be the new best friend for any red teamer, right? For the next few months or years, maybe. Who knows? It's gonna be awesome. How often do you guys patch your Office applications? You don't have to answer. It's all right. This process that we'll talk about later on, it's spawning CS script. CS script. Where's that for? right? And then that spawning con host tells you something, right? If you've done a bit of this, you probably know what that con host is doing. We'll see a bit of that later on as well. But there seems to be a connection, right? Connection, host. There seems to be a spawning some kind of traffic going out of my network. And then look at what's going after that. Does it look suspicious? Not really, right? It looks random. It looks like pretty random. So we were talking about that before. We talked about frequency PY, right, being one of these scripts that we can use to detect randomness. This is like pretty obvious for like the human eye, or at least a trained human eye, when you look at something like this to know that there's something weird going on there. That process hierarchy is pretty suspicious. Something else that confirms that there's something suspicious going on with this machine is that there is some connections that we can find in netstat, right? And those connections are going, in this case, that's the attacker's machine, right? It's a local IP, private IP address. But we can see there's a connection established, right, from that same process that we saw before. And there's also a connection that is trying to be established. That is a SYN sent out to the same IP address, same port, from this random process. At this point, right, if you weren't feeling bad about it, you should really feel bad about this. There's something really wrong going on here. Now, this is, as I said, kind of obvious for a human being to look at this data and figure out there's something wrong going on. Now, how much time do you really have for triage at your SOC? Kind of, let me click here, right? And then you do something with it. And then it's like, let me click there. What happens with the rest of the alerts that they disappear, right? They go to death null. They go up into the metasphere. Well, we don't have a lot of time for this, right? So it would be awesome if we would have some analytics, right? Or some kind of scripts that will parse that and will tell us, hey, this is bad. And that's kind of some of the stuff that we've also seen before, some of the scripts that have been shared before. Now, from an engineering perspective, there's a problem with some of this. If you look at the output of this text file, right? This is netstat, for instance. It has a specific format. But if you look at the output of that has a different format, right? It's a plain text file, but how do you parse it? I'm pretty sure that you guys have some kind of scripts that will do something similar. Every SOC has. So you will have one that will parse this and will tell you something, and that's cool, but doesn't it feel that we are reinventing the wheel every single time? Right? I'm sure that if we talk here in this community, that I think we're building something really awesome here, and we talk about the scripts that we have, we will probably figure out that each of you have written the same thing that your neighbor, right, the guy that is sitting next to you has written as well. And we probably, have spent a lot of time doing this stuff when someone else has something that we could already reuse. So think about this. 3 different people, 3 different analysts writing scripts to parse this output. Let's say that we want to have one script that will go through web history and will tell you which ones are naked IP addresses. And when I say naked IP addresses, I'm not talking about those pages that Jake mentioned being found on .tk, right? Domains. That was just useful information, right? Now, I'm talking about those IP addresses, right, that are being used for downloading a stage 2 malware, usually, like .exe, or maybe one suspicious document like that, RTF documents. Why would a user go to http://1234, right, and download a binary from that naked IP address? That's not something that usually happens, right? That's suspicious. That's something that it's not like driven by a normal user, normal behavior. Typically, you would download something from a domain, not from an IP address. So something I would like to do is to create a simple script that will parse that web history file and tell me these are naked IP addresses, and then you can investigate that. Or just check the name or the hash, ideally, right, of this process or this binary against the National Software Reference Library and tell me if this is something known or unknown. None of these things are going to be completely false positive free, but it's going to narrow down the amount of data that you have to look at. So it's going to speed up triage, which is a good thing. Or just tell me if that process name has entropy, right? If it's random, if it's something that could be machine generated. If we get 3 different people to come up with a script for this, I guarantee these scripts are going to be completely different, and worse over, you will not be able to reuse the output of someone else's, right? Because we just come up with different solutions. So that's something that doesn't give you traceability, doesn't tell you how objects can be manipulated. It doesn't give you the ability to get Justin's script and the output of his script, pipe it into my script, and then the output of that, pipe it into someone else's script. Because you may want to orchestrate some of these and say, look, for this particular process list, I want to check if it's in the NSRL, and then for those that are not, I want to see if they have a random name. See what I'm going to, right? That would be awesome. So we were thinking about this problem, and we thought, well, it's not a problem of collecting data. There's lots of different scripts that can collect data. You might like them better or not. I wrote rastrea2r because I couldn't find a solution that was useful for that particular environment, but you might be using something completely different. And there are plenty of other solutions out there. So I was thinking, let's normalize that data. We were talking about normalization and our love for JSON, right? Don't we love it? Now let's burn it down. And kudos to Austin for this, right? I had to ask him yesterday. It's like, hey, dude, I want to do that same thing with the flames. I want to burn that. I love JSON. And we actually started the project I'm going to show you now, thinking about using JSON, and then we ended up using CSV for the reasons you're going to see now. So that's the solution that one of the solutions that I'm proposing here, which is essentially using Open CNA. Open CNA stands for Collection, Normalization, and Analysis. And what we do is we take the output of any tool, but we're using rastrea2r here. We normalize it, put it into CSV, and then create analytics that can be shared with the community. So I'm going to show you the framework, the idea. We're releasing the code today, so it's going to be on GitHub. I'm going to give you the link. And the idea is that you as an analyst, if you want to write an analytic that will do something specific, you don't have to worry about the normalization of the data. You don't have to worry about what other people has done about this. You just take the SDK, which is written in Python, and it has all the wrappers for manipulating these CSVs, and you just ingest the data, do something with it, and then output to standard output, right? And other people can take that specific analytic and use it and orchestrate it and do something with it. So these analytics, we're going to wrap them into Dockerized images. Why? Because it's nothing better than putting together 2 buzzwords, machine learning and Docker, together into a project. So we went for this. But the idea is that each of these analytics will be in each of these images, self-contained, and they will take this input, right, standard input, and they will output to that standard output. And these are the ones that we're going to share, and I'm going to be doing a little demo here, right? Yeah, Docker, lots of Dockers. So this is how it works. You have on the first step, you have the extractor of the snapshots. You have this pipeline that will extract these entities at that point. For the output of rastrea2r, it will create these CSV logs. Then it will get these logs into the corresponding Docker that we want to use. And this is where you choose the one that you want to use, something that is fit for this purpose. And then we'll extend those types. You're going to see that. This is more like engineering speech, but you're going to see how it works. And the idea is that you can stack this process, you can pipe these analytics, and you can orchestrate what you want to do with this data, but without having to worry about how you write those scripts on how the data is normalized. If you download the code today, if you just do a git clone, it will download all of these different files that you can see there with the README, the analyzer, and this script build.sh. This build.sh will download those Docker images, and it will also compile the Open CNA client for your machine. So we'll install Open CNA client there, and you will be able to execute it. And these are the Docker images that we'll download that we have available right now. I'm going to show you. I'm not going to show you a demo of how to download that, right, or how to build it, because it will take quite some time. What I'm going to do is I have a video just as a backup in case things go wrong. Not that that ever happened, but I felt like, hey, let's do a live demo, right? So let's go for it. Thanks for the encouragement, by the way. Okay, so let's see what we have here. So I just did a git clone from the repo, and we have these two different folders. Can you guys see that, or is it too small? And so we have these two different files here that I brought from rastrea2r, and this is the exact same machine that clicked on the user clicked on that link, and we've seen all of these funky things going on. So what we do here is let's use Open CNA, and we can see the help here. Okay, let's see the help, all the different things we can do. So we can use this with normalize and analyze. So I'm going to normalize this data. Actually, you can go into the directory collector. There's a README file. It says, place the rastrea2r endpoint snapshots in this folder, and they should have this format. Okay, so it's good to have some help. So how does it work? We do Open CNA, normalize. It says, oh, you need input folder, and we're going to need an output folder as well. So we're going to say input is going to be collector, output is going to be normalizer. All right? So if this works, now we'll go through the zip files with the files from that snapshot that we took out of this image, and it's going to parse the output and create CSV files, right? That are normalized, and you have all of these nicely aligned columns for the output of each of these different files. In this case, we don't have all the output of rastrea2r here. We just finished this literally like last night. That's usually what happens. And but I have a few files that I can show you, so we can go into Normalizer. And if I get into Triage, you see that there's these different files. So you have the output of netstat, for instance. Right. CSV format. You have also, what's this? Process list. Okay, so you have this host name, process ID, name, description, everything is nicely aligned. Okay, so what can we do with this? Let's start with the web browsing history. Let's get into this directory. This was all created by Normalize, and let's have a look at what we have on this web history demo CSV file. Let's do this. Okay, so this is the sample file with all this browsing history. It's not a lot of stuff, but just for demo purposes, it might serve the purpose. It's everything that we extracted out of the browsing history from this machine. Okay? Cool. Thanks for encouragement. This is just like Nearsoft or all the tools that we just execute against this endpoint, right? So again, it's not rocket science. It's just a wrapper for a lot of the stuff that we want to run on the endpoint. It's just that we are orchestrating all of this, automating it. Okay, so what we can do here is say, look, I'm going to get these contents of this file, and I'm going to pipe it into Open CNA, because I want to know, and this is the analyze part, I want to know if there is some naked IP addresses in there. And now, it's a proof of concept, right? You could just go through the file and see it, but imagine that you have lots of different machines, different snapshots, so you want to automate this somehow. So if we look at Analyze, you have these options. These are the 3 Dockers that we have available right now. So let's try the web history. If I do this, it's going to say, hey, I'm missing something. I'm missing an argument. That C stands for column. So I have to fit this with a specific column, which I know it's URL, but you can do this as well. Head -2. right? So it's the URL, that's the name of the column. So what I'm going to do is Open CNA, analyze web history minus C, URL. And now, and this is the kind of the extension of the types. What we're going to do is we're going to add a column. That column is going to tell me whether there's a random, a naked IP address on that URL or not. And you choose how you want to call that column. You can call it after Smurfs if you want. This is going to be isNaked. All right? So I'm going to do this. It's going to go through the file and see that it just added a column here. Can you see that? Right? In some cases it's false, some cases it's true. So if you want to see if there's any, you can kind of see it there. You can say, show me just all the ones that, for which there's a true value. So these are the naked IP addresses, right? Imagine you're doing this with a very long file, and you can see just those are the ones I want to focus on. Why is that someone is downloading something from this IP address? So that's something that can be automated. What else? Let me show you something else quick. Let's look at the other modules. Let's say that I want to find if there is any process there that has some a name that has some entropy, right, or level of randomness. So what we're going to do is we're going to look at this file, process list. Let's look at the headers first, because I want to focus on this particular field. This field is called name. And what I'm going to do now is I'm going to use Open CNA, analyze. Let's see, what's the name of the module? Random process name. Okay, let's do that. Random process name. And it's going to ask for the same thing, right? Minus C, name. Okay, so let's do that. See if it works. Sorry, I forgot something. I forgot to say minus O is random, right? So I can have that extra column there. Should go through it, and now we have this extra column saying, no, this is false, this is not random, this is not random, as expected. Okay, so let me grep for any random stuff. Is any of these process names or any of these random? And as expected, what we see is the process, right, that we saw as with a high degree of entropy or randomness there, which is essentially, this is a kind of a meterpreter agent running on that box. So I did some persistence, I established some persistence on the machine once I hacked onto that machine, and then a meterpreter creates this agent that runs every 5 seconds to see if you can establish back connectivity to the bad guys, right, to the attackers through command and control. And look at where this is running from. You could potentially have another analytic and say, now from these ones, show me which ones are running from a temporary directory, right, or a suspicious directory. Now, to show you how to stack this, or how to pipe this, let's say that in addition to this, you want to check for which ones are not on the NSRL list. It's uncommon. So you can do process, uncommon, NSRL, and then minus C name, minus O, that's a column we're going to add, is in NSRL. All right? Let's do that. Let's just get the first 10 one, let's say. So it doesn't take longer. And see what we're doing here is we're running one of these analytics, right? We're piping the output of that one into the input of another analytics. So you can orchestrate this as you want. And for something like this, we're going to look at, right, see that we added 2 columns here. First one is if it's random. Second one, if it's on the National Software Reference Library. So we're looking for something that is random and that is not on the National Software Reference Library. So I'm going to grep for, going to grep for something that it's random, so that's true, and that is not on the National Software Reference Library. And then we should be getting more information about this same process, right, that we spot running out of temp. So it is random, and it's not there. Now, I don't have the time to show you everything that we have in here, but you have the machine learning models. There's some of that in there. We're sharing the models with you. We are not sharing the training material, right, and the source code for that training material, because we still have to go through the legal teams to see if we can share that. But I'm doing my best. And we're sharing some of these, obviously all the Python source code for all of these different parsers, normalizer for this output. And I plan on keep working on this, adding more stuff. But obviously the whole idea of this is that we put it out there for the community so you guys can see if this is useful and add some other containers, some other analytics, and build something cool from here. So that's right. This is was the demo part, right? But yeah, where's the machine learning there? So for the data scientist gigs, what do we have there? We have random forest, we have PCA, we have statistics, Markov processes, and whatnot. I'm sorry to talk about this. I know at this time of the day, right? The last talk. But some people might be thinking, why are not we using like frequency PY? Frequency PY is awesome, right? What it does is actually some probabilistic statistics on something called bigrams, right? So bigrams is like taking two contiguous characters at a time to figure out whether they are in the normal English dictionary. And we talked about that before, right? Seth talked about this before. So what we're doing here is we're extending that concept. What we're doing is we're taking the bigrams, we're also taking trigrams, which is like 3 contiguous characters. We're also looking at the entropy of these characters, and we're applying random forest to see all the different combinations between them. I know it's sick, right? This is actually made by people that is way smarter than I am. But I love working with this group of people because they're data scientists, but they're not security practitioners. So when we get together, cool things happen. It's like they have these ideas, they know how to implement it, and we have a need, which is doing this kind of stuff. So if you want to know more about that, feel free to ping me later on. If you're wondering what's going on with that particular attack, our new best friend, this is something that was published last week, right? I think it was last week, Jake? Well, he always knows before the rest of the models, right? But yeah, for the rest of us, I think it was last week. And it's a vulnerability that has existed for about, 20 years, right? In Microsoft Office. So what could go wrong with this? The patch was available, I think last week. That was when it was made available by Microsoft. So if you haven't patched it yet, right, patch now. The exploit that I used, and I didn't have the time to show all of that, but it's really simple. If you want to play with that, I'd encourage you to do so. John was talking about the importance of doing red teaming in your environment. I think it's a great way of maturing your operations, of getting new signatures, right, or new detections built into your scene, new use cases. Do this, right, and rehearse this with real-world attacks. This is something that everyone is throwing at you right now, and they're going to be throwing this at a lot of people for a long time because they know that people don't patch. Right? If they don't patch OS, imagine like applications like Office, and this is used worldwide. So you have the reference for the exploit. That link on GitHub is actually the exploit that I used. So you can use this to create a payload that you can wrap with Metasploit, right? Inject this interpreter, call back home, and establish the session, and then play around with it, do persistence, and see if you have the ability to detect these things, lateral movement, etc. All right, so that's what we're releasing today. So feel free to go to this GitHub repository. We have a bunch of open source stuff there. That's part of my job as well, to share stuff with the community. That's what I love to do. Everything I've learned is based on this awesome community that I've been working with for almost 20 years now. And I feel that we're obliged to give back to the community and put these tools out there, especially when it's not rocket science. It's based on the work that all the people has already done before. So that's pretty much from me now. And if you have any questions, I don't know if we have time for this. Yes.
Hey, real quick on the equation editor thing. Two pieces here that are really, really interesting. One, it's really, really old, and Microsoft lost the source code for this. They didn't write it originally, and they don't have the source code from the people that originally built it.
Oops.
They generated the patch in binary. So some engineer had to go in and generate the patch for this. there's blood in the water, and every exploit developer, not that I do that or anything, on the planet is looking at this hard right now. So this is one of many to come. We'll just say that the code, not the source, but the binary is a hot mess.
Right. Thanks for the context. Yeah. Someone from Microsoft is just leaving right now. I don't know why. It's like oh, no, he's still there. All right. I was just joking. Any other questions?